In the last two lectures, we have developed an overview of chilled water and condenser water piping. In this and the next few lectures, we will learn how to size the various pipeline components, beginning in this lecture with the pipe itself. Note that when water flows through a pipe, there will be a pressure drop due to friction, and this pressure drop has to be overcome by the pump. Commercial considerations limit us from choosing very low friction values, since this will lead to large pipe sizes and very high cost of the pipe. An acceptable friction loss of 4 feet of water column per 100 feet of pipe is typically used for pipe sizing. In order to decide the size of the chilled water pipe, we use ISHRAE HVAC Databook 2017 figure 3.1, which is the closed piping system chart. If we know the flow rate and the acceptable friction loss per 100 feet of pipe, we can then pick off the pipe diameter from the chart. We can also pick off the corresponding water velocity in feet per second. Let us now take up an example, that is a chilled water line in which a flow of 300 GPM is required. On the chart in ISHRAE HVAC Databook 2017 figure 3.1, we first draw the 300 GPM horizontal line as shown. We can see from the chart that in case we choose a 5-inch diameter pipe, the friction loss will be 1.5 feet of water per 100 feet of pipe. While if we choose a 4-inch pipe, it will be 5 feet per 100 feet of pipe. Since the 5-inch diameter pipe results in a loss less than 4 feet of water per 100 feet of pipe, we select the 5-inch diameter pipe as suitable for our use. We can also read off from the chart that the 5-inch pipe gives us a water velocity of around 4.8 feet per second. When it comes to the condenser water pipe sizing, we should use the open piping system chart, that is HVAC Databook 2017 figure 3.2. Let us now take up a condenser water line example in which a flow of 400 GPM is required. We use figure 3.2, where it is seen that a 5-inch pipe is not suitable since it gives a friction drop of 5 feet of water per 100 feet of pipe. However, a 6-inch pipe is suitable since the friction drop will now be 2 feet of water per 100 feet of pipe, that is less than our limit of 4 feet of water per 100 feet of pipe. Note that very low water flow velocities, that is less than around 2 feet per second, are not desirable. The velocity should be high enough to propel forward any air bubbles to the point or points in the pipeline where they can be captured and expelled. In the next lecture, we will see how air is removed from the chilled water line, since the presence of air in the chilled water line can be detrimental to performance. Thanks for watching.